Recall that our goal is to create a probability model that describes the long-run behavior of proportions from random samples. Previously, we used an applet to collect a few random samples to get acquainted with making a distribution of sample proportions. We randomly selected 25 students at a time from a population of part-time college students that is 60% female. In the next random sample, we predict what happens in the long run when we select many random samples of 25 students at a time from this population. Then we watch a simulation to see if our predictions are correct. Now here's the example, predicting the behavior of sample proportions. Based on our intuition and what we observed from the applet, we might expect the following from the distribution of sample proportions that came from a proportion where P, the probability, was 0.60. The center, some sample proportions will be on the low side, such as 0.52 or 0.56, and others will be on the high side, such as 0.64 or 0.68. It is reasonable to expect all the sample proportions in repeated random samples to average out to the underlying population proportion 0.60. In other words, the mean of the distribution of sample proportions should be P. So that's like if this is 0.60 on some scale, all your random samples, they should be close by. They'll be maybe a little smaller, maybe a little bigger, but they'll all kind of focus on that same 0.60. The more random samples you take, the closer and closer you see that these are getting to. The average of all of them will get to 0.60. And then the spread, for samples of 25, we expect sample proportions of females not to stray too far from the population proportion of 0.60. Sample proportions lower than, say, 0.44 or higher than 0.72 will be unusual. Previously, we took smaller random samples of 8 and observed more variability in the sample proportions. We therefore think that sample size plays a role in the spread of the distribution of sample proportions. Smaller samples may be less accurate and more variable than larger samples. The shape. Sample proportions closest to 0.6 will be most common, and sample proportions far away from 0.6 in either direction, smaller or larger, will be progressively less likely. In other words, the shape of the distribution of sample proportions may be somewhat bell-shaped, kind of like we were drawing up here. The sample proportions might be small, they might be big, they might be smaller than 0.60, larger, but the majority of them will be really close, and it'll end up looking like this, kind of like a bell-shaped curve, yeah, like they mentioned. Let's move down, okay. All right, now we use a simulation to collect numerous samples to see what happens in the long run. We use the simulation to check whether our intuition about the center, spread, and the shape of the distribution of sample proportions is right.